Okay, welcome to the second video. So in this video here, I just want to really get started. So what we're going to do is we're going to run. So I need to compile the chess project.java file using the Java command, and then we're going to the javac command. Now we're going to run it. So when you run it, you should get this this board here. So we have the white pieces, the black pieces, and it says let's play some chess. Choose your AI opponent. Now for the continuous assessment, you're going to need to capture this and then implement the AI player. But for this, we're not actually capturing anything, even though I like clicking on the random moves. And when we click on the piece here, we see that we're making a random knight move. And what happens is when we look at the code, when we look at the screen, all of the squares that are in green are potential squares that the AI agent could have chosen to move to. The code is implemented for all the pieces bar the pawns, so none of the other pieces can move past these pawns, which tells us that they recognize that their own piece is sitting right in front of them. So what happens is when the game starts, the AI agent says, where can I move to? It looks at all the potential moves that all of its pieces can actually make, creates a stack of these potential moves, and then invokes one of those movements. And if we have a look at the terminal, so there's some output happening here for us. And we can see that we start here, we have Java chess project, and then inside of these kind of lines here, we can see that we have the white knight can move from 1, 0 to the following square to 0, 2. And the white knight can move from 1, 0 to the following square, 2, 2. So we follow the mouse here. If we say 1, 0, well, this is the 1, 0 position up here because it's 1 in the x and 0 in the y. And then we can move from 0, 2, so 0 in the x pulls us back to this column here, and 2 in the y brings us down the board to this square here that's highlighted green. Or we can move to 2, so 2 in the x, which brings us over to here, and then 2 in the y, which again brings us down the board to this highlighted square here. Similarly, if we look at the rest of the output here, we have the white knight can move from 6, 0 to 5, 2, and the white knight can move from 6, 0 to 7, 2. This identifies the square 6. If we count over here from 0, 1, 2, 3, 4, 5, and 6, following the mouse cursor, we can move, and 0 being the first row in the y, we can now move to 5, 2, so 5 brings us back 1, and 2 brings us down 2 squares, which is where we've actually moved to. Or we can move to 7, 2, which brings us over 1 square and then down 2 in the y direction. We can see here that we had 4 potential squares that we moved to, and then it says the AI agent randomly selected a move, and the move was the white knight from 6, 0 up to square 5, 2. And the move that's actually made, we highlight the squares with a red border going around them. So we can see the red border here around the square where we actually invoked the move. Okay, so this is coded in, so you can use this, yeah? And then as I make a move, so it's black's turn to move, when I move, we can see then that what happens is we can make other such movements. Okay, and we can see that there's lots of other movements that can actually be made now. And we can see we have this knight here can move to this square, following the mouse again, this square. It can't move to the square here where the mouse is because its pawn is there. The other knight, which was here, can move to this square where the mouse in front of the pawn. It did move to this square here, but it also could have made a number of other moves, including back to the origin. We can also see here that the white rook has now freed up because there's a space beside it and it can move over in this direction now. Okay, so what's happening is we're making random moves, and as you can see here, as I'm playing, the number of potential moves that's happening is getting bigger and bigger. And once I start to take some pieces, it'll open up even more. Now if I move my knight out of the way, the bishop can now move all the way down here, and the queen can also move all this way down here to take this pawn. So once we get those pawns moving as well, we're going to have 20 initial moves that the actual white pieces can make. So we have 16 movements for the pawn. So a pawn can either move 1 square or 2 square to start. And then each of the knights can also move to 2 possible squares. So that gives us 8 by 2, which is 16, plus the 2 moves for each of the knights. So it's 20 moves initially that the AI agent should be choosing from. Okay, now, so let's just take a little look in the code. So what we'll do is, because the white pawns aren't actually coded up, what we'll do is we'll just comment out those white pawns, yeah? So here's where we're putting the pieces onto the actual board, and what we'll just say is, look, we don't need those pieces on the board for now. And I'm going to recompile. And then when I run it this time, I shouldn't have any of the white pawns on the board, which you see I can't, so I'll just remove those white pawns from the board. And this time when I click random moves, we should see a completely different picture. So now we can see that there are lots and lots of squares that have been highlighted. So essentially now, there's all these potential movements. So the rook can move in a horizontal way, so right with this way down here to take this pawn. The queen can move directly down the board here. It can also move along this diagonal if you follow the mouse movements, and also down this diagonal. And as you can see, that all of the pieces are actually coded up. Okay, so it's very important for you guys to have a read through the code to see how we're doing this, and then to be able to invoke that same strategy on making the white pawns move. Okay, and again, if we wanted to play this game, whenever a black moves, the AI agent is making a random movement. And unless it has become self-aware, they should be silly movements, as they clearly are. Okay, so we'll leave it there. So remember, if you want to mess around and make sure that you can test certain pieces, the idea here is whenever the AI agent is making a move, it decides, okay, what moves are possible. And then if we look at the code here, from line 73 to 80 is where we can hide putting the white pieces on the board. And then we scroll down through the code, we can see that there are various functions here. Here's where we're getting the rook movements. We scroll down, we have get the bishop movements, get the knight movements, get the landing squares to find the white pieces, and so on and so on. If we look here at make the AI move, so inside make the AI move, we simply reset the borders. So we change the color of the borders back to being no color at all, so blank. We validate it and we repaint it. We find all the white pieces. This gives us the stack of where all the possible white pieces start from. We instantiate a new empty stack for the complete movements. And then while we still have potential pieces in the stack, what we're doing is we're going to loop through that. We pop them off, we cast it to a square. So now we have a potential square. We get the name, we get a stack associated with the square. And what we need to be able to do is to see if the piece that's sitting on that square is using the get name is a knight, a bishop, a pawn, a rook, a queen. So if we wanted to actually hide any of the pieces, so we don't want to test the knight anymore, we can simply comment out the knight, or whatever pieces we want to comment out, and when we compile them and we run it again, we're not going to be catering for the knight moves or the bishop moves. So you can incrementally test this if you want to see exactly what's happening. Okay, so we'll leave it at that.